Hello everyone, again welcome to our YouTube channel. Today we are going to discuss unit number 3, Limit, Fit, Tolerances and Gauges part 2. Myself Mr. Bipin Patil, lecturer, Department of Mechanical Engineering at Sharat Institute of Technology, Polytechnic, Yatra. So what we have learned in previous lecture, so let us take glance at a previous lecture content. So in previous lecture we have studied the concept of limit, fit and their definitions. We have studied deviation and tolerances, definition of both. Then we have discussed about the basic terminologies: normal size, basic size, actual size, zero line, hole, shaft. Then we have discussed about hole designation, shaft designation. After that we have studied about selective assembly and interchangeability. So coming to the today's lecture content, today we are going to see classification of limits, limits of hole and shaft, maximum and minimum limit. Then we are going to learn about classification of tolerances. Basically there are two main types of tolerances, unilateral and bilateral. Then after we are going to learn what is mean by compound tolerance, what is mean by geometrical tolerance. Then we will turn to Indian standards fits, that is IS 919 and 1993. Then we are going to study about the types of fits, clearance fit, interference fit and transition fit. So let us start with today's content. Starting with the concept of limits. So today we are going to learn what is mean by limit. So previously we have seen the definition of limit: two extreme permissible sizes between which the actual size is contained is called limit. So there are two types of limits, that is upper limit, or we can say it as a maximum limit of size, and lower limit, or we can say it as a minimum limit of size. So what is mean by upper limit or maximum limit of size? So let us see the greater value of out of two limits, that is maximum permissible size of that particular job. So similarly, what is mean by lower limit? The smaller value out of two limits, that is minimum permissible size of a given job. You can see here in image, here it is showing the hole and shaft with their tolerances. This particular hatched line section, which is called tolerance zone. Here the minimum limit or the baseline is called minimum limit, and the upper line of a tolerance zone is called maximum limit. So maximum limit of size and minimum limit of size is applicable to the both hole and as well as shaft. So this is the concept of a limit, maximum limit and minimum limit. Also the tolerance definition says that the tolerance is equal to difference between maximum limit and minimum limit. So it is the tolerance zone. So let us turn to the, here you can see the example of a maximum and minimum limit. Here 25 mm is a basic size, and plus 0.2 and minus 0.2 mm are two tolerances. Here you can see the maximum limit, basic size plus tolerance, that is 0.2. Here you can see that 25.2 mm is maximum limit of that particular hole and shaft. Also you can see here minimum limit 25 minus 0.02 is equal to 24.8 mm. That is the minimum size of that particular limit, or you can say the minimum limit or least limit of that particular hole and shaft. Here is the basic size 25 mm. So this is the concept of a limits, that is upper limit or maximum limit, and lower limit, that is minimum limit. So going to the next concept, that is tolerances. So as we discussed in previous lecture, the concept of tolerances, what is meant by tolerance. So again, take a glance at a definition of a tolerance, that is the difference between maximum limit and minimum limit of hole and shaft is known as tolerance. So there are four different types of a tolerances, or we can say the system of tolerances. So let us see the first, unilateral tolerance, bilateral tolerance, compound tolerance, and fourth one is a geometrical tolerance. These types of tolerances are so important as the industry and industrial drawing point of view. So let us see the first type of a unilateral tolerance system. Here, unilateral tolerance, the total tolerance as related to basic dimension is in one direction. You can clearly see in image, and this type of tolerance is preferred in interchangeable manufacturing system. So how exactly the method of expression in unilateral tolerance takes place? See here. Here you can see 25.0 mm and 25.1 mm is clearly seen here. It is a type of a unilateral system, that is the dimensions lie only at a one side or in one direction, that is plus direction. You can clearly see here. Then 25.1 mm and 25.2 mm, that is plus 0.1 plus 0.2, both are in at plus side, you can see. Similarly, you can give the unilateral tolerance at minus side, or you can see below the zero line. Second example shows here how exactly unilateral tolerance expressed in minus or negative direction or negative side. Here 25.00 mm, 24.9 mm. So this is 0 and minus 1 mm at one side, and second example 24.8 mm and 24.7 mm, that is having tolerance minus 2 mm and minus 0.3 mm. So both tolerances are at negative side. So it is the type of a unilateral system. Next we will see advantages of unilateral tolerance system. It is easy and simple to determine deviations, hence used for precision fits. Second, it is also simple to design inspection gauges for checking components. Third, such kind of system can be adopted in drilling process, and it is preferred in mass production system. So let us see the next. Second, bilateral tolerance. When the tolerance distribution lies on either side of the basic size, it is known as bilateral tolerance. In other words, we can say the dimension of the part is allowed to vary on both sides of the basic size. You can see in the image here, but may not to necessarily equally deposit about it. That means it is not necessary that here it is the plus 1, and in other hand you can see below the negative side, it should not require the same tolerance given, that is plus 1. You can place here as per your convenient tolerance, that is minus 2, minus 3, minus 4, whatever you want. So let us see how exactly the method of expression in unilateral tolerance takes place. Here 25.1. So here the examples of unilateral tolerance. how exactly unilateral tolerance takes place. So in first example you will see there are the upper and maximum limit of a same tolerance, that is plus zero point 0.2 and minus 0.02. Second, 40 plus 0.02 minus 0.03. This can be also the unilateral tolerance. And again, in third example, you can see 40 at plus side 0.05 and at negative side it will minus 0.01 mm. Here in figure you can see that how exactly for a particular length of a cylinder unilateral tolerance is placed 40 plus minus 0.02 mm. So either you can set it as a 40 plus 0.02 and minus 0.02. So coming to the next system, that is compound tolerance. So let us see the definition of compound tolerance. When tolerance is determined by established tolerances on more than one dimension, it is known as compound tolerance. For example, tolerance for the dimension R is determined by the combined effects of tolerances on 40 mm dimension, on 60° plus minus 2° and on 20 mm dimension. The tolerance obtained for dimension R is known as compound tolerance. As per the figure or as shown in figure, you can see the particular tolerance of a R is determined by this dimension tolerance, that is 20° plus minus 0.01 degree. Here also you can see it tolerance given to the angle, that is 62 or 58°, that is plus minus 2° to 60°. And here the base length is also tolerated up to 40.02 mm and 39.98 mm, that is plus minus 2 mm. As per these such dimensions, the exact dimension of R or tolerance of R is setted. Here in practice, compound tolerance should be avoided as far as possible. So this is the final type of a tolerance system, that is geometric tolerance. As you can see in the figure, geometric tolerances are used to indicate the relationship of one part of an object with another. Consider the example shown in figure. Here you can see there are two cylindrical parts which are correlated with each other. Here the x datum is referenced as, in feature control it is given, the concentricity can be vary or can be tolerated up to 0.01 with respect to that x datum. So here are two different cylindrical parts, that is we can say it as a part number 1 and here it is the part number 2. So the concentricity of a part number 1 with respect to concentricity of part number 2 can be tolerated up to 0.01 mm. So those were the four types of a tolerance system, that is unilateral, bilateral, compound tolerance and geometric tolerance. So we are going to study about the Indian standard fits, that is IS 919-1993. So let us see in detail the classification of a fits. Here you can see in tree there are three main types of a fits, that is clearance fit, transition fit and interference fit. Here again the further classification of a clearance fit is done in sliding fit, easy slide fit, running fit, slack running fit and loose running fit. In second type, in transition fit, again it is classified in push or snudge type ringing fit. And finally, in interference fit, it is further classified in force or press fit, driving fit, tight fit, shrink fit, and freeze fit. So in detail, we are going to study the types of fits and their applications. So let us see the first type, that is clearance fit. So what is mean by clearance fit? Here you can see upper limit of shaft is less than the lower limit of the hole. The two graphical representation seen here, you can see the hole and shaft basis system. Here it is seen that the two tolerance zones of shafts are less than the tolerance zone of a particular hole, or you can see the lower and upper limit of a shaft less than the lower limit of a hole. So clearly it is seen that there is a clearance between these two pairs. So you can see the largest permissible diameter of the shaft is smaller than the diameter of the smallest hole. Carefully examine the both diagrams. Here you can see the clearance between upper limit of a shaft and lower limit of a hole. So the example of particular fit is a shaft rotating in a bush, or you can see the sliding fits all over placed in any application. Those are the examples of a clearance fit. So let us see the next type of fit, that is interference fit. Here in interference fit, upper limit of the hole is less than the lower limit of a shaft. So in both diagram you can see the both tolerance zones of a hole and shaft. Here you can see the tolerance of a hole is less than the tolerance of a shaft. So you can clearly see that the lower limit of a shaft is having maximum dimension than the upper limit of a hole. So you can see no gap between the faces and intersecting of material will occur here. So to make such type of fit, shaft need additional force to fit into the hole. Here exactly how the representation of a interference fit is shown. So such type of a fits are or can be seen in the fitting of a spindle or chuck on a spindle of a lathe machine, or the mountings of bearing in the bearing mounting hole. So let us see the third type of a fit, that is transition fit. Third IS fit, that is transition fit. The diameter of the largest permissible hole is greater than the diameter of a smallest shaft. So here you can see it can make clearance as well as interference fit. So you can see in the image the tolerance zone of a hole and tolerance zone of a shaft is combined, that is the upper limit of a shaft is less than the upper limit of a hole, and the lower limit of a hole is greater than the lower limit of a shaft. So it is neither loose or neither tight like clearance fit and interference fit, and tolerance zones of the shaft and the hole will be overlapped between the interference and clearance fits. So these are the three types of a fits, let us see the applications of transition fit and interference fit and clearance fit. So coming to the applications of a fit, the first application in clearance fit, that is sliding fit. These types of fits can be seen in sealing the rings, bearing covers, movable gears, in change gear train, clutches. Second, you can see the easy slides in lathe spindle, spigots, pistons and slide walls. Third, running fit, that lubricating bearings, pump and smaller motors, gearboxes, shafts, pulleys. These are the applications of running fit. Then next, slack running. Oil seals with metal housing, multi-spline shaft are the example of slack running fits. And finally, in clearance fit, the last fit is loose running fit. That is loose pulleys, loose bearings with low revolutions are the types of a loose running fits. So coming to next application, that is interference fit applications. So in interference fit, the first type of a fit is a force or press fit. You can see the application, the crank pins that are pressed or forced to make assembly, then car wheel axles, bearings, bushes in castings. Then next type of a interference fit is driving fit, that is plug or shaft slightly larger than the hole. Then tight fit, that is stepped pulleys on the drive shaft of a conveyor. Then shrink fit in interference fit applications are bronze crowns on worm and worm hubs. Then couplings, gear wheels and assembly of piston pin in IC engine pistons. Then finally the freeze interference fit, insertion of a exhaust valve seal, insert in engine cylinder blocks and insertion of brass bushes in a way various assemblies. So this is all about the today's lecture, that is limit, fit, tolerances and their applications. So this is all about today's lecture. If any queries or doubts, ask in comment below. Thank you. Thank you very much.